Okay, hi guys. So in this lecture, we'll be seeing the calculation of n factor. Okay, so let's get started. Calculation of n factor. So first, let's define n factor for acids and bases. So it is defined per mole. Okay. So for acids, we have the number of moles of H plus furnished or produced by 1 mole of acid. Okay, or in other terms, we can also call as basicity of acid. Okay, for example, if we say we have HCl, HClO4, HNO3. For HCl, n factor would be 1. Okay, and for HClO4 also it would be 1, and for HNO3 also it would be 1. So these are examples of monoprotic acids or monobasic acid. Okay, so if we have some acids like H2SO4, again aqueous, H2C2O4 or H3PO4 or rather H3PO3, let's take. So n factor here would be can be either 1 or 2, and max n factor here would be 2. Okay, let's see another example where we have H2SO4 aqueous plus HNO3, or rather not HNO3, let's have NaOH aqueous reacting together to form NaHSO4 aqueous plus H2OL. Okay, so here n factor here that would be used would be only 1, because it is only denoting 1 H plus, and the other H is already written by H as HSO4 minus. So here n factor for H2SO4 is 1, and obviously n factor for NaOH would also be 1. Okay, it is an example of incomplete neutralization. Okay, next let's have an example where when you have H2SO4 aqueous reacting with 2 moles of NaOH aqueous to form Na2SO4 plus H2OL. So here n factor of this used would be 2, because both the hydrogen atoms are replaced with sodium atoms. Hence the n factor for this would be 2, and for n factor of this it would be 1. So this is an example of complete neutralization. Okay, so let's take an example of H3PO4. Okay, so in case of H3PO4, what will happen is H3PO4 is first of all a triprotic acid. Okay, and N factor of this can be max 3, and but it can be 1, 2 or 3 with N max as 3. Okay, so next let's see an example on the same. Suppose we have S3PO4 aqueous reacting with NaOH and forming NaH2PO4 aqueous plus H2OL. So in here N factor used would be, or N factor of S3PO4 in this reaction would be 1. And let's say if we have another reaction in which we use S3PO4 aqueous again plus 2 moles of NaOH again aqueous to form Na2H PO4 plus 2 moles of H2OL. So here N factor for S3PO4 in this case would be 2, because 2 hydrogens were replaced by Na2, and here N factor for NaOH would be always 1. Okay, so this was an example of, the above one was, these two rather were examples of again incomplete neutralization. Okay, now the example of complete neutralization can be when all the 3 H plus from S3PO4 were utilized with 3 moles of NaOH aqueous to form Na3PO4 plus H2OL. This is aqueous. So N factor here for NaHPO4, S3PO4 would be N equals to 3, and the N factor here would be 1. This is an example of complete neutralization. Okay, so if you have to talk about the equivalents, so equivalents here would be, equivalent is defined as number of moles into N factor. Number of moles of S3PO4 was used is 1 and N factor is 3. Equivalents for NaOH would be number of moles of NaOH used is 3 and N factor is 1 here. So you can see that the number of equivalents in both the cases, or after the completion or at equilibrium in the reaction, would be 3. Okay, so 3 equivalents of S3PO4 would be equal to 3 equivalents of NaOH. Okay, so with this we come to the end of this lecture. In the next lecture we'll be seeing N factor for bases.